Okay, so on this one you're in degrees, so first check your mode. Make sure you're in degrees, and they want these round to 4 decimal places, and we're going to do quite a few of them. So on your mode, go ahead and change it to 4 decimal places. And this is just for practice on your calculator, okay? Okay, so on the first one, sine of 58 degrees. So you know the angle. Okay, so go ahead and just do sine of 58 and press enter. Okay, and I get 0.8480. Okay. Cosine of 37. So just do cosine 37, and I get 0.7986. 7986. Okay. Everybody okay with that? Okay, tangent of 41. So tangent 41 degrees, and I get 0.8693. Okay, 0.8693. Okay, then they go from just degrees to degrees in minutes. So do sine of 33, and then remember you have to do second function angle. Pick up the degree symbol, and then 20 minutes. So put in the 20 and second function angle. Pick up the minutes, and I get 0.5495. Okay with that one? Okay. Now, number 5 starts the reciprocal. Okay. You still know the angle. So this is like cotangent is like 1 over tangent. So that means you want to figure the tangent of 9 degrees 40 minutes and then get it down in the denominator. So go ahead and figure tangent. Pick up the 9, do second function angle, pick up the degrees, 40, second function angle, pick up the minutes. Okay, now you can do this a couple ways. You can go ahead and press enter, and then do the x to the -1, the reciprocal key that will move it down. Or you can close the parentheses and do the x to the -1. The x to the -1 key is the reciprocal key. Okay, so you end up with 5.8708. Now on that one it's not a bad idea because you're just getting used to your calculator. So to go ahead and say, how did we enter it? We went ahead and put in tangent of 9 degrees 40 minutes. This is the critical part. You close the parentheses, and then we did the x to the -1 key. That comes from the reciprocal key. Okay. Okay. Secant's a reciprocal with what? Cosine. So you want to do cosine of 25. Pick up second function angle. Pick up the degree symbol. And 30. Second function angle, pick up the minutes, and it's a reciprocal, so you want to close the parentheses and then the reciprocal key, x to the -1 key. Okay, so you've got 1.1079. You agree with that? 1079. Okay, then and if you want to do that out at the side, so you know this is for you when you get ready to review the calculator. Okay, so it would be 25 degrees, 30 minutes. And then you got to do the close the parentheses. You may even want to highlight that, or okay, you got to close the parentheses. If you don't, you're going to get the wrong answer. Cosecant's a reciprocal with sine. So you want to do sine 14, pick up second function angle, pick up the degrees, 50, second function angle, pick up the minutes, close the parentheses, and then the x to the -1 key, reciprocal key, and I get 3.9061. Okay. Okay, now we're going to go, they give you the value of the function, and they want to know what's the angle. Notice you've got to look at the directions. You can't ignore this. When you read this, you always want to read it from the middle. Don't start 0 is less than or equal to theta. The way you read that is you start theta is greater than or equal to 0 and less than or equal to 360. So you're looking at all 4 quadrants, and they want you to round to the nearest tenth. So for this one, you can clear your calculator and then go to the mode, and let's go to the nearest tenth, one decimal place. We're still in degrees. Now, when you know the value of the function and you don't know the angle, that's when you do inverse sine, inverse cosine. So we want to do inverse cosine. So that's second function cosine. Okay, so it's going to look like this on your calculator. Inverse cosine. Don't read it cosine to the -1. You read it inverse cosine, and then the calculator puts in the parentheses, and then 0.4226. I also need to look at this part right here. Positive or negative? It's positive, so cosine's positive in 1 and 4. So my answers ought to be in quadrant 1 and quadrant 4. Okay? So put in inverse cosine of 0.4226. Okay? And I get 65. So now when you write this, the cosine is gone. What's left is the angle. You're finding the angle theta. Do you need that 0? Yes, because it's nearest tenth. Okay? And then theta is also in quadrant 4. So you got to draw your little picture. Okay, go around into quadrant 4. It's just a sketch. Okay, we know this angle's the 65.0. What I want to figure is this angle that gets you there. So on your calculator, if you take 360 minus that answer, second function answer, and you should get 295.0. Okay. Notice on these, when you're doing the other quadrants, you will never ever use 90 or 270. It's always going to be either 360 or 180. Okay. Okay. On number 9, first thing, look at the SIGN, and there's nothing there, so it's positive. Sine is positive in 1 and 2. Okay? We know the value of the function. We don't know the angle. So that's when you do inverse sine of 0.1190. Okay, and I get 6.8. And notice that's the theta. Theta, the angle, is 6.8 degrees. Or, now you go into quadrant 2, the sketch. So we're going to start on the positive side, go over into quadrant 2. And this angle is 6.8. What I want to know is, how do I figure this angle? So what do I have to do on the calculator? Other way around. 180 minus that answer, right? Right? 180 minus that answer. Yep. 173. 173.2. Okay. And again, you could put those angles back in for theta, and it ought to be close to this. It won't be exact because we rounded to the nearest 10. Everybody doing okay? Sure. Okay. Are you caught up to there?
Yeah.
Okay. Okay, so tangent. Look at the SIG, and tangent's positive on this one, so it's positive in which quadrant? 1 and 3. Okay. Okay, so we know the value of the function. We don't know the angle. When you don't know the angle, that's when you do inverse. Okay, so we want to do inverse tangent of 6.6912. Okay, and then press enter. Okay, and I get, for angle 1, 81.5. Okay. Everybody okay with that one? Okay, so then we need to go into quadrant 3. So draw a sketch for quadrant 3. So you got to start on the positive side and go over into quadrant 3. Remember that perpendicular goes back to the x. So this angle inside is 81.5. So now you've got to figure this whole thing. How do you go from here all the way to that terminal side? So what do I have to do on the calculator? Yeah, add 180. So we already have the 81.5 on the calculator, so just go plus 180. Okay, so our other angle, our other theta is 261.5. Okay. Any questions on that one? Okay. Now we do the reciprocals. Okay. We still know the value of the function. We don't know the angle. Okay. You want to look at the SIGN. Okay. It's positive. So sine is positive in 1 and 2. And this is a reciprocal, so it's also positive in 1 and 2. Okay, so on your calculator, you don't know the angle. So anytime you don't know the angle, that's when you do inverse sine, inverse cosine, inverse tangent. So it's inverse sine of 3.1790. Now, this one's the reciprocal one. It makes a difference where you put that reciprocal key. On this one, you don't close the parentheses. You put the x to the -1 key. So you may want to write down, we're doing sine, inverse sine of 3.1790, and then the reciprocal key. Okay, and press enter. And I get 18.3. Do you agree with that? Okay, that's our quadrant 1. Okay. Everybody okay with that one? Okay with that one? Okay, now we're in quadrant 2. Okay, so sketch. So go over into quadrant 2. Perpendicular always comes back to the x-axis. Okay. And then this would be 18.3. Okay, so now I need to figure this angle. So on your calculator, what you really need is 180 minus that answer, second function answer, and that's above the negative key. And I get 161.7. Okay. Everybody all right with those? Okay, now look at this one. Secant is positive. Secant's a reciprocal with what? Cosine. And its cosine's positive in 1 and 4. Right? 1 and 4. Okay, we know the value of the function. We don't know the angle. Okay, so that's when you do inverse cosine of 24.56. And it's a reciprocal, so it's the x to the -1. And I get 87.7. So that's our quadrant 1. Okay, now you're in quadrant 4. So sketch in quadrant 4. Okay, so this angle is the 87. That's the reference angle. Remember, they call that the reference angle. And the reference angle is always positive inside the triangle. Okay, so then on that one, we would need to take 360 minus that. So on your calculator, take 360 minus that answer. Okay, 272.3. On these, it's a good idea to emphasize your decimals so you know where they're at. Okay. Okay, that's a little review of what we did on the calculator yesterday. Okay, now I'm going to take you through. We did the 30, 60, 90, 45, 45, 90, Now we're going to do a little bit with the right triangles. Okay, a little bit of practice with the right triangles, if the angle's not a special angle. Okay, so put this in your notes. Okay, okay, on the directions, find the length of the unknown x to the nearest tenth, and our calculators are still on tenths, so we're okay. And then on this, for the angles, if they ask you to find an angle, find theta to the nearest minute. Okay? On angles, they might say nearest tenth, nearest hundredth, nearest minute, nearest second. This one, they want it to the nearest minute. Find the length of the unknown x to the nearest tenth and theta to the nearest minute. Okay, now on problem 13, draw a triangle. Label this angle. Okay, label this as 66 degrees, 30 minutes. Which, that one's 30 minutes. You could say it was 66.5 degrees. You can go either way. Okay, label this angle is, or this side is x, and this side is 27. Okay, now I want to find x. In terms of this angle, in terms of that angle, what side is this? It's the opposite. And what side is this? Adjacent. Now you have two possible trig functions, tangent or cotangent. Okay? When I do right triangles, I usually, because of the keystrokes on the calculator, I usually try to put the unknown up in the numerator. It saves keystrokes. Okay? So on this one, if I do tangent opposite, that puts the unknown up on top. Okay? So for our trig function, okay, we're going to write tangent. And it's not a bad idea to go ahead and just say tangent of theta equals opposite over adjacent. And then sub in. Okay? If you're at that stage where you know those definitions well enough, okay, then you can go to the second line. Tangent of 66 degrees, 30 minutes equals the opposite over the adjacent. Okay? Okay? So, on your calculator, figure the tangent of 6630, or 66.5. Let's simplify it. That simplifies keystrokes. So let's do tangent of 66.5 and press enter. And you may want, for this part, because we're doing, let's go ahead and go to 4, and then we'll round it, because I want you to be able to see that whole thing. Okay. What I do want is you ought to be able to say, show me this much. Okay. Whenever you do the trig functions, they're 4 decimal places. Okay, now, to solve for x, read that x. A lot of times I say it x over 27. I really should say x divided by 27. What's the inverse of division? Multiply. So multiply by 27 on both sides. Okay, so on your calculator, take it times 27. Okay, and x equals, and if we round it to the nearest tenth, it'd be 62. If you want to, for me, I'm going to go ahead and write that down so somebody taking notes. It's like 62.0957. And then if you round it to the nearest tenth, you look at this. So that's 5 or greater, so we're going to round it up to 62.1 is our x. Okay? And that's how you solve right triangle trig using the calculator. Okay? And find an unknown side. Okay? Any? Which part? Did you do tangent? 6. Let me see your calculator. That's kind of weird. Because you typed this in. Yeah, that's why. Yeah, let me explain that. That answer, her answer is a little bit different, and it will be. So yeah, you don't want to just type this in. You want to do this on the calculator. Why? Because let's do this. If I go back to floating, and if I just type in tangent of 66.5, see how many decimals are behind that? That's why. Yeah, so if you just type in that for this example, yeah. But when you're doing the homework and in the test, you don't want to just type that in. You want to Yes. Yeah. 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 It's just the difference between you gotta do this part and then multiply by 27. You can't just type that in because the calculator rounds it. Okay. Okay. Everybody okay with that one now? Okay, let's do another example. Okay. Okay, on this triangle, okay, this angle, 37 degrees, 30 minutes. Again, 30 minutes is half a degree, so you could go 37.5 there. That would be all right. This time, what is the x in this triangle? That one is the hypotenuse. Remember the side opposite the right angle is always the hypotenuse. What is this angle in relation, what is this side in relationship to this angle? Adjacent, because it's touching. Okay, now, we have two choices. Okay, we could go cosine, adjacent over hypotenuse. That puts the unknown down in the bottom. It means more keystrokes. Okay, you always want to try to put that unknown up on top. So you want to do hypotenuse over adjacent, which is secant. So when we do this, we want secant of 37.5, that's all right, 37.5 degrees equals the hypotenuse. If you want to go ahead and write it out, hypotenuse over the adjacent. So I would do secant of 37.5. The hypotenuse is x. The adjacent is 25. A lot of people try to avoid those reciprocal ones, and it's to your advantage not to avoid them. It's just like fractions. You don't want to avoid them. You want to just attack them. Okay, so you have to go through what we did on the calculator. Okay, secant of 37.5. We know the angle. So you go ahead and figure cosine of 37.5. You have a choice. You can press enter and then get the reciprocal key, or you can close the parentheses and do the reciprocal key. Okay, so for that much, now you round it for the paper, you don't round it on the calculator. Okay, round it for the paper, don't round it on the calculator. Okay, so we end up with 1.2605. You can go 4. 4 is okay. Okay, and then you'd have equals x divided by 25. Now you want to solve for x. Do the inverse, multiply by 25 on both sides. So x equals. So on your calculator, take it times 25. So x, and they want it rounded to the nearest. I'm going to write it out so anybody taking notes. And then you round it to 31 point. You'd look at that and round it to 31.5. What if I said round this to the nearest hundredth? What would it be? 31.51. Yeah, and what would it be if I said round it to the nearest thousandth? Yeah, 0.512. Yeah. So it makes a difference in the directions. Okay? Everybody okay with that one? Okay, another picture. Notice the right angle this time. Right angle is up here at the top. Okay. Make this angle 28 degrees, 40 minutes. This leg is our unknown x, and this leg 54. Okay, get the picture drawn first. In terms of this angle, what leg is this? Opposite. What leg is this? Adjacent. It's easier. Now I've said it. Have you written it down? It's easier on these as far as keystrokes if you put the unknown up in the numerator. So we want the adjacent. So if you do adjacent over the opposite, which trig function is that? Cotangent. So we actually want cotangent of 28 degrees 40 minutes. So cotangent of 2840 equals x divided by 54. Okay, we know the angle. Okay, so you go ahead and figure tangent of 28, pick up the angle, second function angle, pick up the degrees, 40, second function angle, pick up the minutes, close the parentheses, and then it's a reciprocal, so you got to do the x to the negative 1. Okay, and I get 1.8291 if you round that. Now, I'm rounding it for the paper, but I'm keeping the whole value on the calculator. Okay, read that as x divided by 54, do the inverse. Okay, multiply by 54, so take it times 54. Okay, and I get 98.7694, and then they want it rounded to the nearest tenth. So you look at the hundredths, so it'd be 98.8. You agree with that?
Yeah.
And that's our x. Okay. Okay. When you punched it in, did you go tangent of 2840, close the parentheses, and then the x to the negative 1 key? And then take it times 54. Okay. Okay, on the next one. Okay, look at right. I've got the right angle up here at the top. Okay. So what is this? What's the x? The hypotenuse, right? And the angle over here to the right I have is 42 degrees 10 minutes, and this leg is 32. So in terms of this angle, and the unknown's the hypotenuse. The hypotenuse, what's this leg? Opposite. So I want the hypotenuse over the opposite. What trig function? Cosecant. So I want cosecant of 42 degrees 10 minutes. Okay. So cosecant of 4210 equals, the hypotenuse is x, the opposite is 32. So on your calculator, sine of 42 degrees, second function angle, pick up the degrees, 10, second function angle, pick up the minutes. Okay, close the parentheses, and then the x to the negative 1 key. Okay, and I get 1.4897 equals x divided by 32. So multiply by 32 on both sides. Okay, and if you round that, and then if you round it to the nearest tenth, you got to look at this and round it up, 47.7, and that's x. Okay, on that one. Okay, now what happens if we don't know the angle? Okay, on this one, draw a triangle, draw a sketch. I've got the right angle up here at the top, but I'm solving for this theta. Okay. In terms of this angle, What is this side? Opposite. This side? Adjacent. So trig function, tangent. Okay? So I'm going to do tangent of theta equals the opposite over the adjacent. So tangent of theta, my opposite side is 56, adjacent side is 23. Okay, now, read that. Like I said, I fail a lot of times because I read it 56 over 23. It's really 56 divided by 23. So on your calculator, do 56 divided by 23. Okay, so really we've got tangent of theta equals, now I'm going to round it for my calculator, or for the paper, I'm going to round it for the paper, 2.434948, right? Yep. Okay, now, I know the value of the function, I don't know the angle, that's when you do inverse tangent. So do inverse tangent, and don't type in 2.4348. What you do is you use the answer that's on the calculator. You don't want to round in trig until the final step. Okay? So you want to keep all that on your calculator. So even if you did floating, changed it from floating to 4 decimal places, that's fine. The calculator still has it on there. Okay? So do inverse and do second function answer. Inverse tangent, second function answer. Okay? And I get 67.67, and if you rounded that, they want it to the nearest, what did they say, nearest minute, didn't they? Ooh, now we got to go back to degrees minutes. So do second function angle, and go back to degrees, minutes, and seconds. So when you first get this, you're going to have 67.6713 degrees, and they want it to nearest minute. So you got to do second function angle and go to degrees, minutes, and seconds. Remember when we did that? Okay, so our final answer now, you have to look on your calculator at the seconds over here, okay? At this part, if this is 30, right? 30 is halfway. So if this is bigger than 30, you would round that up. Okay, but it's not. It's 67, 40, 16. So final answer is 67 degrees, 40 minutes. Okay? Okay? Okay. Another example. This one, the right angle's down at the bottom. Put your right angle down here. We're solving for theta. Okay, in terms of this angle, what's this side? Opposite, and this side? Adjacent, because it's touching. Okay, so opposite and adjacent. So tangent would work. Tangent of theta is opposite over adjacent. So tangent of theta, our opposite side is 130. Our adjacent side is 90. Now again, a lot of people just stop when they get that on the test and they're going, well, I don't know what to do there. You got to read that as 130 divided by 90. So on your calculator, take 130 divided by 90. Okay, and I get 1.4444. Okay, now you know the value of the function, you don't know the angle. So you do inverse tangent of that answer. Don't type in 1.444. You want that whole value on the calculator. Okay, and then round it to 55.3048. That's degrees, but that's not what they asked for. They asked for the nearest minute. Okay, so we got to do second function angle. Go back to degrees, minutes, and seconds. Okay, again, I've got 55 degrees, 18 minutes, 17 seconds. Okay, if this is 30 or below, you leave it. So 55:18, 55 degrees, 18 minutes is our final answer. Last example. Okay, some of these they will give to you in the form of word problems. Okay. When the angle of elevation of the sun is 53 degrees, a tree casts a shadow 6.5 meters long. When the angle of elevation is from horizontal up. Okay, so picture-wise, you're going to have something like this. When the angle of elevation of the sun is 53 degrees, the tree casts a shadow 6.5 meters long. Here's our tree. Okay, this is the 53 degrees. The sun would be out over here somewhere. Okay, here's our shadow. Right here. Oops, shadow. 6.5 meters long. How tall is the tree? So we're really figuring this X. Same idea, and they want it to the nearest tenth. So in terms of this 53 degrees, what side is this? Opposite. Adjacent. So again, you can do tangent. Tangent of 53 is opposite over the adjacent. Tangent of 53 is x divided by 6.5. Okay, so figure tangent of 53. Okay, and it's 1.3270 equals x divided by 6.5. So to solve for x, you're going to multiply by 6.5 on both sides. So just take what's on the calculator times 6.5. Okay, and they want it rounded to the nearest tenth. So I've got x is 8.625. So you're going to look at this and leave at 8.6, and that would be in meters. Okay. Okay.